Okay. So we are going to get into a new data structure today called a stack. And it is very, very similar to a queue. And so before we get into what makes a stack, I want to briefly review the code for our queue class that we wrote the past two classes. Okay? So these are on Canvas, like I mentioned. I'm just going to pull them up here. And let's briefly take a look at all three of the classes, because what we're going to do for our stack is going to be very similar. Okay. So we've got our three classes along the bottom here. We have our queue class, our linked queue. We've got our customer class. This is the object that we are instantiating to actually put in the data structure. And then we have our driver, which we call snow cone fuel. Right? So let's take a look at those briefly and the differences between them. So in our linked queue class, up at the very top, we have references to two customers. Okay, we have a reference to the customer that's front and a reference to the customer that's in the back. Okay? We need direct access to the front of the line and the back of the line so that when we remove from the front, we have direct access to that front customer. That's what gets us O1 for removing. When we add, we have direct access to the back because we're always going to add to the behind whoever's already last in line. Okay, that's how we get O1 for adding in the back. Okay, remember, NQ means add, DQ means remove. Okay? So those are the first and the last references. When we instantiate our queue, we simply set first and last to null. We have a little helper method that checks to see if our queue is empty. And we do that by simply checking to see if first equals null. Because if there's no one in the front of the line, then there's no one in the line. We have an NQ method, and we have a DQ method. And that wraps up our queue class. Now, taking a look at our NQ method, the logic for this is going to be similar to what we're going to do with a stack in just a little bit. We check to see if the line is empty. If it is, then we also set the first to reference the customer we're adding. If not, we take the person that's last in line and set their next reference to the customer that we are just adding. And then we always update the last because the customer that we're putting in the line is going to be the new last person. Okay? We'll hit this more. I'm not going to spend a bunch of time on this because we're going to get to this when we get to stacks in just a second anyways. But I do want to review the other two classes briefly. So looking at our customer class, this is the object that we're, again, instantiating over and over again to put into our queue. We have two fields that we keep track of for the customer. The first is simply an ID. We just use this so that we can identify different customer objects. Okay, this doesn't really serve any purpose. If we were going to actually create a program that really utilized this, we would need to keep track of more information for the customer, their name, all that sort of stuff. This simply demonstrates how a queue works. The other field that we have up there is a next reference that has the ability to reference another customer object. This is necessary because we are creating a linked queue. We're using a linked list as the basis for setting up our queue. So we need each customer to be able to access other customers or reference other customers. Okay, so that's why that next reference is there. When we create a customer, we simply randomize their ID number and we set their next reference to null. This is pretty standard practice whenever you're using some sort of linked list, setting the next reference to null. We have a couple getter and setter methods that we can access and modify whoever is next in line, and a simple two-string method for this. Okay? Questions on customer? All right. And then looking at our driver, really basic stuff. We're just showing the functionality here. First line of code creates our queue. Then we simply loop through 5 times and we add 5 customers. Okay? So notice right here, there's no reference variable. This is important. There's no reference variable that refers to these customer objects. Okay, we're simply creating customers, and then we're taking the memory location of where that customer is created, which is what gets returned from the constructor. We're taking that memory location, which refers directly to that customer object, and we're passing it to the enqueue, or the add method of our queue. All right, so there's no intermediary reference variables that we're dealing with. We're simply creating customers and passing them straight to the add method. Okay? Coming down after we add them, then we remove all 5. We do that by saying line.dequeue. Notice we don't pass anything to the dequeue method because it's automatically going to return whoever's in the front of the line. It's going to remove them and return them. Okay? No need to specify which one we want to return. What's up?
What does it actually print when you dequeue someone?
Good question. So when you dequeue somebody, if you look at the dequeue method, notice that it returns a customer object. Okay, so it's going to return the actual customer object. In Java, if you output or if you pass a reference to an object to the print line method, the default is that it's going to call its toString method. Okay, so that's basically what's happening here. If we ran this, we would see just its ID number pop up because that's what we do with the toString method. It's the same thing as doing this, saying dot toString. Okay, it's just kind of shorthand for doing it. Good question. And then we finally add one at the end just to show that we can add and remove, and that's what we've done. Questions? We good on queues? Okay. Again, this is on Canvas. Video is on Canvas. Go back and check it out if you need to. What I want to get into now briefly, and I think I should do it up here, stacks. So let me close out all 3 of these. And now let's talk about stacks. Stacks are very, very similar to queues. In fact, there's only one difference. Stacks, like queues, have very specific rules for where you add and where you remove from. We visualize queues like people waiting in line for something, whether it's coffee shop or snow cone stand or grocery line or some line online, waiting in line for a queue to get into some program or to get access to something. Okay? That's what a queue is. First in, first out, new objects added to the back, objects removed from the front. A stack is typically visualized vertically. Okay, where you have a stack of papers, or a stack of books, or a stack of cafeteria trays. Okay? Anybody ever been to a buffet? Everybody probably. Is there a buffet around here?
Yep.
You said that really fast.
I love it. Yeah, it's good. It's good.
It's good.
That's good. So when you go to the buffet and you walk up to the line, okay, all the food in front of you, there's typically a stack of plates, right? Do you grab the plate on the top or the bottom? No. Most people grab the plate on the top, unless you have like a really weird germ thing, then you're probably not eating at a buffet anyways. But why don't you grab the plate on the bottom or the middle? Why do you grab the one on the top? You could.
It's more trouble than it's worth.
There you go. You could take the whole stack, set it aside, grab this plate. And you don't do that because why? All the plates are the same. And there's no point in going through all that extra effort because you just want the next one. Okay? And that kind of gives you some insight into when you would use a stack. Stacks are useful when you have a group of objects that are either all of the same or you're going to use them in the same way. You use a stack when you just want to keep track of a bunch of objects, and when you need one, it doesn't matter which one you need. You just grab one off the stack. Okay, they're all the same. Does that make sense? In one of the other classes that I'm teaching right now, we're making a game where, let's show my age here. Anybody remember playing Crossfire when they were little? One person. Crossfire is a game where it's a two-player game, and it's not a video game, it's an actual like board game kind of thing. You have like this little gun that you can rotate, and the other person has a gun they can rotate, and you shoot, and it shoots like little marbles across. And the goal is you're trying to get this disc into the other player's side, and the other player's trying to get the disc into your side. So you're shooting back and forth, and that sort of thing. And so we're making a game that's like that. Okay? And you've got, in our game, you've got a series of turrets that you can click on to shoot, and it shoots out marbles. And instead of having a disc, we've got like a giant soccer ball that we're trying to get to the other person's goal. And the other person on the other side is trying to do the same thing. So as you're doing that, and you keep clicking on the turrets, marbles keep shooting out. Okay? Now, in game design and programming in general, creating new objects is something that's rather expensive. Okay? And so if you can avoid creating new things over and over again, that's a good thing. That's a kind of an efficiency thing that you can do to optimize your stuff. And so typically what is done is while the game is loading or starting up, you go ahead and create a bunch of them. So you might create 30 or 50 marbles. Okay? And if you've ever played a game and you've seen it like loading or caching resources or loading resources, that's probably what it's doing. It's going ahead and it's creating a bunch of those marbles. And what we do in that game, in the game we're working on in the other class, that's exactly what we do. We create, I think we create 30. And we set them aside. And when we set them aside in a stack. Okay? Which is why you take this class early on, because the other classes that you take after that assume that you know how this stuff works. Okay? So we create those marbles and we set them aside in the stack. So we have a giant stack of marbles. When we click on a turret, we simply grab a marble off of the stack, attach it to the turret, and shoot it. Okay? When the marble goes off and it falls down or whatever, in our game it falls down, goes down a trap, and it hits thing at the bottom, and when it hits this catch thing at the bottom, which you can't see, it throws it back onto the stack. Okay? So it gives the impression that all of these marbles are being created, but we're really just reusing the same set of 30 marbles. Okay? Which is way better performance-wise than every time you click on a turret, creating a new marble, which is not what you want to do. Okay? But when we pull a new marble off the stack, does it matter which marble we get? No, because they're all the same. Okay, so in situations like that, maybe you're shooting bullets or you're shooting little kittens out of a cannon. There's games like that. You laugh because you played them.
Yes.
There's no need to create them each time. You simply have a stack of them. All right. So here's the rules for the stack. Okay. You remove from the top of the stack. It's the easiest place to get to. Okay. So you remove objects from the top of the stack. Now you can visualize stacks horizontally. Typically they're done vertically, but it doesn't matter. If you're going to turn them on the side, then you remove from the front, just like you do with the cube. Okay, so you remove from the top or the front of a stack. Now, if you go to the buffet and you see one of the guys that works there, maybe he washes or she washes dishes, brings out a bunch of dishes back from the kitchen, you're going to put them on top of the stack. Okay? Now, do they take the dishes and set them aside and then pull all of the objects off of the stack, set them aside, and then put the new ones on the bottom? No, where do they put them? Why? It's easier, that's right. And why is it easier? Why can we get away with that? Well, because they're all the same. So, when the marble gets finished and it falls down the chute, we throw it right back on top of the stack. Because it's easier to get to the top of the stack than it is to get all the way to the bottom. Okay? Now, when we finish, after we finish this program, I don't know if it'll be today or next class, I will show you how it works in the other games. You can actually see how it works. And we've talked before about, is it okay to use the built-in data structures that languages provide? Is that okay? In this class, no. Because you need to know how they work. You need to be able to code them for multiple reasons. We've talked about that before. Okay, it makes you a better coder, it's blah, blah, blah. Okay, it's true. You need to know how to code them. In that game, we use the default stack. Okay, but in the game that I made the semester before, we needed one that had slightly different functionality. And so we coded it ourselves. So there's going to be times when the default one, very basic implementation, is what you need. There's also going to be times when you need functionality that's slightly different. So you need to be able to code them just in case you need to do something different. Okay? This makes sense. So stack, add to the front, remove from the front. Or add from the top, remove from the top. Yes, sir?
So where queues were first in, first out, the stacks are going to be first in, last out?
Last in, first out.
Okay.
The last one that's in is the first one that's out. So you said first in is the last one that's out.
Last in.
Last in, first out.
Okay.
FIFO and LIFO is how they're typically done. First in, first out for queues. LIFO, last in, first out. So the last one that's in is the first one that's out.
Okay.
Right? Everybody good with this? We ready to code it? Okay. So, good note taking, huh? I wrote stacks in it. Good notes. Sometimes it's just easier to explain. All right. So just like with our Q program, we're going to need 3 classes. We need a class for our data structure, which is going to be our stack. We're going to need a class for the object that we're putting onto the stack. And then we're going to need a driver, that demonstrates how it works. Adds, removes, and that sort of thing. All right. Before we get into the coding, there is a special term that means add and a special term that means remove for stacks. So we had enqueue for add and dequeue for remove when we were talking about queues. For stacks, to add to a stack, it's called push. Don't ask. I guess you push it. You push an object onto a stack. That's how you add it. So, if you push to add to a stack, what do you do to remove it?
Pull.
That would make sense, but that's not it.
Push out.
Push out. Unpush.
Unpush.
We were playing a game on our trampoline, and I forget what it was. And my son kept saying, okay, time out, because we had to pause for something like that. And then instead of saying time in, he would say untime out. No matter how many times I explained to him, it's not untime out, it's time in, or continue, or anything else. It was untime out. So not unpush. To remove from a stack, it's called pop. Okay, we're going to pop it off of the stack. Okay, so pop is remove, push is add. Okay. And why are these terms important? Well, these terms are important because if you go to use the default implementation that a language provides, so for example, the game that we're coding, we're doing it in C#. Okay, so if we want to use C#, which is a .NET-based language, if we want to use their stack implementation, we create a stack, and then if we try to say stack.add, there's no add method. You're like, well, how do I add it? It's because the method is called push. And if you don't know that, it's going to take you a while to figure out how to add to your stack. Okay? Same thing with remove. Push and pop. Okay? Questions on that? All right, let's do it. So, first class, there's a public class linked stack. We'll do a linked implementation of the stack just like we did a linked implementation of the queue. You guys should probably figure out that the code's going to be similar because the rules are similar. In fact, the only rule that's different is where you add. Instead of adding to the back, we now add to the front, or the top. Okay? But this will give you good practice. All right, so I'm going to save this. Now let's create our class for whatever object it is we want to add to the stack. So what do we want to add to our stack?
People.
People.
Or cafeteria trays.
Cafeteria trays. Okay, what's the craziest thing you can come up with?
People.
Cards.
People.
No.
Marshmallows.
Marshmallows.
Puppies.
Okay.
Winged marmoset.
What?
Winged marmoset.
I don't know what that is.
Go with that.
Winged marmot.
Marmoset, you know.
Butterflies?
Isn't that like a mammal?
Rodent?
Yeah, like a flying squirrel.
Let's go with marshmallows. Did that spell marshmallow?
I
think it's M-A.
It's M-A-L-M-A. Marshmallow.
That's definitely more.
I'm pretty sure that's what it is. Or am I crazy? I'm probably crazy.
Did you mean
Oh, you are right.
It's the mall.
We can make marshmallows.
That'd be actually great option.
Yes. Only if you can make a program that makes marshmallows.
Oh, that's easy.
All right. Marshmallow. That's weird. We're going to go with it. All right, marshmallow. I hit save. And then finally, what class? I'm just going to call it driver. All right, we good? So let's start with our marshmallow class. So we're going to create a stack of marshmallows. You can add to the top of the marshmallows. And so we need some sort of unique characteristic of our marshmallow that we can just distinguish between the various marshmallows that we create. All right, so the first thing that we need to do, because we're going to use this in a linked environment, is we are going to create a next reference. We've seen this before, right? We need our marshmallows to have the ability to reference other marshmallows. This is how we're going to link them together. Now, whether we're linking them together in a stack or a queue, it doesn't matter. In this case, we're doing a stack. But we, again, are going to use our linked list as the base data structure for implementing our stack. Now, we need some sort of way to distinguish between our marshmallows. All right, last time we did ID, where we just randomized a number. What's a way that we can distinguish between our marshmallows? Fluffiness. Who said fluffiness? I like that one. So we will public int fluffiness. Is that how you spell it?
Yep.
I'll probably say that a lot this year. Not a good spelling. All right, fluffiness. And so when we create our marshmallow, first thing we're going to do is set the next reference to null. Should we randomize its fluffiness?
Yeah, depending on how many.
Sure. We'll randomize its fluffiness. So on a scale from 0 to 99, we will create fluffy marshmallows. Yes, sir.
When it comes to making like a random number in that sense, and we're creating these objects, is there ever a chance that you're going to get the same random number? Or is it
Sure.
different?
Sure.
That's not, and so like for our assignment and stuff, that's okay if that happens. It don't matter.
That's fine. Again, the point of this is to show you how a stack works. If we get two of the same, and the only reason we have this field to start with is so that when we pull up that the canvas viewer thing, we can see where they are. So this is marshmallow with fluffiness 11. We can see it move. It's just so we can keep track of them. That's the only thing. Yeah.
So it's just to keep track, you don't actually need it, though.
You do not need it. It's just so that we can see where it is. All right. What else do we need here? Think back to what we just looked at for we did customers for queues. What do we need here?
Get next.
Good. Get next, set next. We need the ability to change and access what this marshmallow references. So public, void, set next. Okay, so we're going to pass in a marshmallow. We'll set its next variable here. next returns type marshmallow, and we simply return whatever its next reference is. Questions on this? All right, again, I'll put this up on Canvas when we are finished with the program. The last thing that we're going to put here, just like we did for our queue example, we need a two-string method. You don't really need a two-string method. We're going to put one here because if you don't put a two-string method, nothing will show up in the Canvas viewer. So this is, I'm writing a two-string method so that when we do this in JGrasp, we can see the actual fluffiness in the box. Okay. JGrasp takes whatever is in the two-string method, and that's what it uses to display what's in the box, which we'll see in just a little bit.
So is that just a JGrasp thing? or-
It is just a JGrasp.
Okay.
If you don't write a two-string method, the two-string method from the object class gets inherited down, which returns the memory location. It'll say like, if you don't override the two-string method and you call two-string, it'll tell you what the class is, and then it'll have an @ symbol, and then it'll have a hex number, which is the memory location of where the object's stored, which is useful at times. So we'll say string, two-string, and we'll simple the return. I got to do the empty string, concatenate it with an int to make it a string, so that when we return it, it doesn't yell at us that we're returning an int, and we say we're returning a string. So, questions on this? I went through it kind of quick because we've done it before. But is everybody good with this? All right. Let me save this. And now let's go over to our driver. First thing I want to do in a driver, and I'm going to comment some here, say let's create our stack. So we're going to say linked stack, call it stack, equals new linked stack. That's it. Notice we don't pass anything to the constructor. When we look at the constructor, well, we haven't written it yet, but we won't pass anything there. We'll add some marshmallows to the stack. So stack dot, what's the method for adding?
Push.
Push. Okay, so inside of here, we'll say add a new marshmallow. Again, we don't pass anything to the marshmallow constructor. We look at the marshmallow constructor, no arguments. We randomize its fluffiness. Now, we could put this inside of a loop so that we add several, or we could simply just type it a bunch of times. I'll put it inside of a loop. We'll add 5. Let's stop there. Okay. Let's go over to our stack class. Let's write our push method, and we'll see if we can get our marshmallows actually added, and then we'll deal with removing. All right. Let's go to our stack class. Now, if you remember back to the queue class had how many variables? Remember? Or can you tell me what one of them was?
Size.
Size. Good. What else? First and last. Good. So they had references to the first object in the list, and the last object in the list. We also kept track of how many objects there were. Yeah, I think we kept track. You should if we did it. You should. All right. Now, why did we need a reference to the first object in the list and the last object in the list? Anybody know? Let's start with this. Why did we need access to the first object in the list?
See if there was a list.
Okay, good. That's how we checked to see if there was anything in the list. Okay, what else?
To pull something off the front.
Good. If we wanted to remove something, we needed access to the line, and we needed access to the front of the line. So very good. Why did we need a reference to the object that was last in the list?
So that when you add a new object, you can point it to have its pointer. Yeah, you can have the pointer. Yeah.
Very good. So if we didn't have a reference to the last object in the list, what we would have to do to add somebody to the back is we would have to iterate through the entire list. So for example, let's just say we've got You four right here are a queue. Okay? And we only have access to right here. You're the front. Okay? If I wanted to add a fifth person, which would go after you, and I didn't have direct access to the back, I would have no way to get to you without going through. You say, your next reference. You, next reference, next reference, next reference, and then we put you there. Okay, that changes the complexity from O1 to O(n). Very good. Because we have to go through n objects, where n is the number of objects in the list. Does that make sense? So simply by adding that reference, we get O1 for adding. Now, if we think about a stack, do we do anything with the bottom or the back of a stack? No. So we only need a single reference to the front or the top. Okay? Does that make sense? Any questions on that? So we're going to declare this as a private type marshmallow, and we'll call it first. You can call it top, you can call it front, you can call it whatever you want. It doesn't matter. We'll call it first. First object. All right. So next thing that we are going to do is let's go ahead and create our. We can create a size too. A private int size. Create our constructor. So linked stack. We don't need to pass anything to it. We will set size to 0, and we will set first to null. When we first create a stack, nothing is in it. So there's no need for us to say what first reference is, because first currently references null, because the stack is empty. And when we create it, the size is 0. And we're going to have a few methods. We know that we're going to need an isEmpty method. So we'll have Boolean isEmpty. Do you remember what we put in the isEmpty method for our queue?
If first is null.
If first is null. Very good. So return first compared to if first equals null. Notice a double equal sign. Not an assignment, but a comparison. Okay. Everybody good with this? Do we need to review why this is okay? Now let's write our push method. So public void push, and we are going to accept a reference to the marshmallow object. Notice we're calling it here stack.push, and we are passing it a new marshmallow object. Here we are receiving a reference to that marshmallow object. And this is what we're going to add to our stack. Okay? Here's what I want you guys to do. I want you to look at the code for a queue. And look at the code for adding to a queue. I'll pull it up for you. Here's what I'd like for you to do. You should take 5 minutes and see if you can code this on your own. One of the skills that you need to develop as a coder is the ability to look at code that you know works. We know this code works. This is how we add to the back of a queue. And modify it slightly to get it to fit with what you need it to do. So we know that we're doing something similar. We are adding an object to a linked structure. In this, we are adding that object to the back of the linked structure. In this, we are adding the object to the front of the linked structure. Use this code to write this. Okay? Take about 5 minutes, do it on your own, and then we'll do it together. Okay?
No, there's no last in stacks. You don't reference the bottom roll.
All right, keep it up, take a couple more minutes so you can get this.
Well, because this is your writing push right now.
Like with the first portion of the AQ, like it's empty, but it stays empty.
No, you don't even get that.
Okay.
Because otherwise you just say it's all. It'll be that.
That's what I call it. And then makes M, and then now, this one
I think you only do these 2 lines.
That's it, one more minute.
Pointing it to something, and you're pointing it to whatever's below it, so it's where it ends up set next to the first, and we'll set the new first to the which is that one. I don't think you need to maybe, just say yes.
I think I did something. And I was just like, you know what? I got it. So I did.
Going into a new phase or bentos is to just not eat all that.
I mean,
All right, let's do this. So if you look and maybe remember back to when we coded the queue, hopefully you'll remember that we needed to be able to handle adding an object when the configuration of the data structure was in different forms. Basically, if the queue is empty or if the stack is empty, how does that affect what we do? If there's only one object in the list, how does that affect what we do? If there's a bunch of objects in the list, how does that affect? We should be good. What has to go directly before the method call is an object. Okay, so what we see here is we're using an object to call a method. When you use an object to call the method, which version of the method gets used? Is it what we pass it or what we use to call it? It's what we use to call it. Good. So when we say m.setNext first, we are setting which object's next reference? M or first? M's. Okay? So in this line of code, we are setting M's next reference to first. In this line of code, we are setting first's next reference to M. Which of these two do we want to do? The first one. Good. Because, like this said, and this is why commenting helps you. You know what you want to do, but you want to make sure your syntax matches up with what you want to do. So a lot of times if you write the line of comment first, it will help you write the line of code. So we said we want to set M, which is our new marshmallow, we want to set its next reference to the current first object in the list. So walking through what we just did, we are setting M's next reference to first, not first's next reference to M. Okay, so it's the first line of code that we want to use, this one. Okay? Now, is this it? Are we missing anything?
Yes.
What are we missing?
Size.
Okay, good. We haven't updated the size. Now, this is one of those things. Do you need to comment that?
Yes and no.
Is there anyone that wouldn't know what that line of code did?
Someone who's never looked at a program before.
Okay, so someone that's never looked at a program before, are they probably going to be coding a stack? Probably not. Okay? Again, it's not wrong to comment it, but there's no need to go overboard. Anything else that we're missing? Let me save this. Let's go over to our driver. Let's compile. Any errors? Yes. Possible loss of precision. Okay, the reason for this is we've got an int. Math.random is going to give us a float. Excuse me, a double. So we're multiplying a double by an int, which is going to give us a double, and then we're taking that and cramming it into an int, which is going to cut off the decimal places. It doesn't like that. Okay. We can get around this simply by doing a couple things. If I take that whole statement and I put it in parentheses, I could say math.round, or I could simply typecast it to an int. We don't really care. It's a random number to us, so we don't really care whether it gets rounded or not, so we'll just typecast it to an int. And this will prevent it from yelling at us, because this is our way of saying we want it to be an int. All right, so save this, compile. That fixed our problem. Now let's go to our Canvas window. And we want to visualize this to make sure that it's doing what we expect it to do. All right, so I'm going to start by stepping into our program. All right, we're currently highlighted on the first line of code inside of the main method, which is the creation of our stack. So it's going to go to the stack constructor, set size to 0, first to null, go back to our driver, and now we've actually created the stack. We have our stack reference variable that refers to our stack object, and I'm going to drop this into the Canvas window so that we can visualize it. Okay? Pops up, size is currently 0, and our first is null because there's nothing in the list. Good so far? Okay. So let's go through. We hit our loop now. Let me close out of these so we can see it a little better. We hit our loop. So we're going to go inside of our loop, create a marshmallow. We're going to take that marshmallow that we just created and we are going to push it onto our stack. So we're saying stack.push, passing it a reference to the marshmallow object that we just created. So now we are in our stack class. We're in our linked stack class in the push method. We passed it the marshmallow that we just created. We're currently referencing that marshmallow with a variable m. So we have a marshmallow with a fluffiness value of 74. Okay? If you notice, just how you read this, notice that there's a line across right here. This separates local variables from permanent variables, okay, or class variables. So stuff that's down here is local. Local variables go away when the method's over. Stuff above this line, or class variables, persist through the methods. Okay? So this m is going to go away, and our goal is to get this up here. Okay? We want it to be persistent. All right? So, first line of code, if we read the comment, it says, link the new marshmallow, which is m, to the rest of the stack. We do that by setting m's, which is our new marshmallow, next reference to the current first object. So if we look at this right here, we see 74, that's its fluffiness, and we see this little black box next to it. What's that black box?
Null.
It's null. What does it represent? What should go in that box? Right, it's next reference. Okay, currently is null. So we want that black box to point to whatever's first in the list. Okay? So we set next first, so we call the set next method of our marshmallow. We set next, it's currently null, nothing changes, which is what we want. Then we're going to set first to m. This is where first is way up here. We want that not to be null anymore. We want it to point to m. So this is where it's going to shift up. And now we have access to it. All right, the last thing we do is we increase size by 1, so our size bumps up to 1 here, and we finish. Now notice the local variable section went away because the method was over. Good with the first iteration. Any questions? This is exactly what we wanted to happen, so this is good. All right, let's go to the next iteration. So we're going to create a new marshmallow here. We're going to create a new marshmallow. Create a marshmallow, go back to the driver. We're going to take the marshmallow that we just created, we're going to pass it to the push method of our stack. First line of code, again, read the comment. It says we want to link the new marshmallow. Our new marshmallow is fluffiness of 75. We want to link that marshmallow to our stack. The way we do that is by setting that marshmallow's next reference to whatever's currently first in the list. Well, the current first is a marshmallow with a fluffiness of 74. So we want to link our 75 marshmallow to our 74 marshmallow. We do that by calling the set next of the marshmallow down here, passing a reference to the marshmallow up here. That's going to link the two. So we do that, set its next reference. Now, notice the green arrow that goes from the 75 marshmallow to the 74 marshmallow. Now they're linked. The last thing that we need to do is we need to be able to maintain reference to our new marshmallow M, and we do that by setting first to M. Right? And it's okay for us to no longer point to 74 because now 75 references 74. Okay, so we're not going to lose any variable references there. Okay? So now we've got this, we've got the beginnings of our stack. Okay? Yes, sir?
So in this sense, if we're DQing, or I'm sorry, if we're popping something out, it's going to take out 75 first?
Correct.
I'm just confused because it says like first, looks like it's pointing to the second one, which is pointing to the first one. It's like, it just looks confusing.
So
First now points to 75, but that doesn't mean it's first anymore. That was just, it's not first, it's second, right?
no, it's first.
It's first.
It's first.
Because that's the one that we're going to pop out if we need, because it's...
Correct.
Okay. All right.
Last in
Yeah.
is the first one out.
It's hard seeing that.
Yeah, the projectors make the colors and lines difficult to see. All right, so let's go to the next one. We bumped up the size to 2. Create another marshmallow. Take that marshmallow, pass it in. So we have a really, really fluffy marshmallow. The highest fluffiness you can get. We got 99. We want it to link to 75, and it's just going to get pushed down. Okay, same thing. Let's go through, push down. We have some really fluffy marshmallows. Notice we just push the stack down. Maybe this is why it's called push, because it just pushes it down. Learn something that maybe push it down, push it down. All right, questions on this? It's easy. Trying to decide if I want to finish it. Let's go ahead and finish. Back to our driver, and let's remove remove all of the marshmallows. So we use our same, instead of stack.push, we'll say stack.pop. We don't need to specify anything because it's going to give us the first one. You know what? Let's stop here. Let's do this. I don't want to rush through this. What I want to do is, I don't want to overlook the practical application of this. And so we could finish really quick, but I think what makes more sense is to extend this in the next class. The reference shifting is something that can be difficult to follow. When we're talking about set next, and we've got all these different things, we're pointing different places. And so I don't want to go too quickly through that. So if we go too quickly through it now, when we get to more difficult stuff, when we have objects referencing multiple things instead of just one in a line, it can get confusing. And so let's plan on doing this. We'll hold off on the rest of our stack program Next class will pick up on it, and then I also want to take some time to look at some actual uses of stacks in programs, not these just silly ones that we're doing in class that demonstrate how they work. Okay? All right, so any questions on what we did today? Okay, I'll see you guys on Thursday. Remember, your program is due. Don't forget.